Hello, everyone. My name is Anna, and today we'll talk about understanding p-values. So, to go over what we're going to discuss, first we'll talk about null and alternative hypotheses, and then we'll go into understanding, calculating, and interpreting a p-value. We'll talk about things to know, discuss the relationship between confidence intervals and p-values, provide an example of using them, and then we'll go ahead and conclude. So first, we're going to talk about the two hypotheses that we use in statistical testing. And these hypotheses are ultimately accepted or rejected based on the p-value. And so the first hypothesis is the null, and this is stating that there's no significant association, relationship, or effect between two sets of data or variables. And in this hypothesis, if we do observe any data, it's ultimately determined to be as a result of sampling or experimental error or a result of chance. We also have the alternative hypothesis, which is what we're trying to prove, and it states that there is a difference or association or effect between two variables. And we determine which hypothesis we choose by using a predetermined significance threshold. It's generally 0.05, but what we do is compare the p-value to this threshold. If the p-value is below that threshold, then we will reject the null and accept the alternative. If it's above or greater than that threshold, then we will fail to reject the null. And we say that because in statistics, we can never prove anything. And this is because there's always the possibility that if our data aligns with the null hypothesis this time, that may be a result of chance or error, and that future data may demonstrate a significant difference that allows us to accept the alternative. So as a result of the possibility of future data allowing us to accept the alternative hypothesis, we will never be able to accept or prove the null. Instead, we will say that with our current evidence, we have failed to reject the null hypothesis. Again, as we mentioned, if we do have a p-value below that significance threshold, then we will be able to accept the alternative and reject the null. So let's talk about understanding the p-value. So after we've determined those hypotheses, we set that significance threshold. As I mentioned, the generally scientifically accepted threshold is 0.05, but this value can range higher or lower depending on the preference of the researcher and how much range, how much variation they're willing to have in their results. So the p-value is a probability value. It ranges between 0 to 1. It's always written in decimal fraction form, and it's calculated with the use of a statistical hypothesis test that we'll discuss later. This p-value essentially states that the probability of attaining results as extreme or more extreme than the observed data set. And the higher the p-value, the more likely it is that any difference of data is related to chance and that there's no true relationship between the data. But the smaller the p-value, the more likely it is that there is a true relationship between the data and that these results are not simply from chance. As we mentioned, if the p-value is below our determined threshold, we can accept the alternative. But if it's above that threshold, then we will fail to reject the null. So this slide is going to talk about some textbook interpretations for a p-value. And so we can see this distribution. We'll have a p-value here of, let's say, 0.02 or 0.04, according to our example. And these are the ways that you can interpret a p-value. So for a value of 0.04, we can say there is only a 0.04% chance of observing such a large or extreme difference in an experiment of this size. We can also say if the two population means or data sets are identical, aka if the null hypothesis is true, that there's no difference, then there's a 4% chance that we would observe a difference as large or as extreme as what we did observe. We can also say random sampling from identical populations. Again, if that null hypothesis is true, then that will lead to a difference smaller than observed in 96% of experiments and larger than observed in 4% of experiments. So there are two ways to calculate a p-value. You can do that manually or with software. The software can be SPSS, Excel, R, etc. There's a lot out there. But all of the calculations are done with the assumption that the null hypothesis is true and that the distribution of data is roughly normal. We can also calculate the p-value manually using these formulas, but again, that calculation will change depending on the type of test, if it's lower or upper-tailed, or if it's a two-sided test. And these letters here demonstrate what the meaning is for the letters in the formula. And then a few things to note about p-values. The first being sample size is important. So as we mentioned, the p-value quantifies the likelihood of observing differences of the same or greater magnitude given the assumption that the null hypothesis is true. And the association between the p-value and effect size has a relationship with the sample size. And so that's why it's important that when we're reviewing and evaluating or when we're creating data, that we're differentiating between the sample size and the p-value and understanding what that difference is. The next important thing to note is that null hypotheses are unlikely to be true. And as we learn in the textbook, scientists are rarely going to perform an experiment where there's a possibility that the null hypothesis is true, because that would generally be an ineffective utilization of resources and time and money if we're just trying to confirm something that is that the status quo is the same. And so, given that information, when we do statistical testing with p-values, it's likely that there's always going to be a difference, even if it's small and insignificant, and that p-value is going to help us determine to some extent how significant that difference is. Another important thing to note is that p-values are not very reproducible, and in a simulation of 2,500 experiments, the researcher found that the middle 95% of those p-values ranged from 0.00015 to 0.689, which is a range of 3 orders of magnitudes and a variety of different assumptions and conclusions about the hypotheses. This finding was supported and verified by multiple studies. And for that reason, knowing that p-values aren't very reproducible, it's important that when we do have a statistically significant p-value, that we are verifying that information with the utilization of future statistical testing and research in order to confirm that relationship that we believe we found. We'll also briefly discuss confidence intervals and p-values. And so confidence intervals refer to the likelihood that the true value of a population lies between designated parameters. We often discuss a 95% confidence interval, and we'll go over that a bit in this image and discuss that. But these intervals ultimately help to determine the precision of our measurements. P-values and confidence intervals are linked. They're reported together in statistical analyses, and they share a inverse proportional relationship. And so as we can see, a 95% confidence interval that doesn't contain the true value of the null hypothesis will have a p-value less than 0.05. But if that 95% confidence interval does include the value, the p-value will be greater than 0.05. Again, 99%, if it doesn't contain the hypothesis value, the p-value will be less than 0.01. If it's 90% and doesn't contain it, the p-value is less than 0.1. And then when we go ahead and look at this distribution here, we can use the white to see the null hypothesis. And in this situation, if we had a p-value within this value, let's say 95% confidence interval, if we had a p-value fall within this range, we would fail to reject the null hypothesis. But if we had a p-value fall in one of these shaded areas, that these would be 2.5% of the distribution on either side, then we would be able to say that we have a value extreme enough based on our statistical significance threshold that these are unlikely to be from chance. They're more likely to be from a true statistical relationship between the variables or data sets. And so for that reason, we can reject the null and accept the alternative hypothesis. We'll also go briefly over an example of a p-value. So let's say we wanted to determine the association between listening to classical music while studying compared to academic performance. And so we reviewed and interviewed 500 graduate students, and now we're trying to make sense of our data. So when we're doing this testing with our data set, The first step is going to be to clarify our null and alternative hypotheses. As we mentioned, the null is that there's no association, there's no relationship between listening to classical music and having our academic performance impacted. And the alternative is that there is an association. And in this case, we're saying increased academic performance. So we're saying that there's a positive association and that if we listen to classical music, we'll likely have an improvement to our grades. And then we'll set our statistical significance threshold and we'll use the general 0.05. Our next step now will be to test or to conduct our statistical significance test. And so let's say that we do that either with software or manually, and we receive a p-value of 0.03. So now we're going to compare the statistical significance. We'll compare our p-value to our threshold. 0.03 is less than our threshold of 0.05. And because it's below that, we can say that this is a statistically significant result. And so for that reason, on to step 4, we can reject the null hypothesis and accept the alternative. And so we can say that given the data that we have, we found that there is a statistically significant relationship between listening to classical music and having an increase in our academic performance. And to conclude, so as we've talked about, p-values are used to calculate the statistical significance of a data set, and they'll ultimately determine which hypothesis we accept or reject. This analysis is important, but there are limitations, including the lack of reproducibility and the fact that the null hypotheses we are reviewing are generally likely to be true. When it comes to confidence intervals, there's a clear relationship between them and p-values. The narrower the interval, the smaller the p-value. And as we discussed, that inverse relationship. And finally, it's important to remember that even when we do find a statistically significant p-value, further testing and research should always be conducted in order to review that association and reproduce the same results that we found. That is all for my presentation, and thank you so much for listening.